Let's dive into paper chromatography. It's a simple technique with some seriously powerful results.
If you've ever seen this happen, you've actually witnessed chromatography in action.
And that's not magic, by the way. It's actually the science of separating different substances.
Scientists call this chromatography. The name literally means color writing. Pretty cool, huh?
The easiest way to wrap your head around this is to think of it as a race for molecules.
In our race, there are two key players, what's called the stationary and the mobile phases. The paper is the racetrack. In science, we call it the stationary phase, because, well, it stays put. And the moving liquid, that's the mobile phase. It acts like a current, carrying everything along. So how does it work? Well, some molecules just stick to the paper more than others. Let's break down this molecular race into three really simple steps.
First up, a little spot of the mixture goes on the paper. That's our starting line.
Next, the paper's edge is dipped in the solvent, but the spot itself stays just above the liquid.
Then the solvent starts to climb the paper, and boom, the race is officially on.
And here's the finish line. The faster molecules travel farther, separating from the slower ones.
But how do we actually measure the results? Call the winner.
We use something called the RF value. It's a simple calculation that helps identify each substance.
You just divide the distance the molecule traveled by the total distance the liquid traveled. Easy.
And here's the key. Every substance has its own unique RF value. It's kind of like a chemical fingerprint.
Okay, a paper race is cool and all, but why does this really matter in the real world?
It's used all over the place, from separating metal ions to analyzing the building blocks of protein.
Because it's so simple and effective, it's a fundamental tool in labs just about everywhere.
The whole point is that even the tiniest physical differences are enough to separate a mixture's parts.
Which makes you wonder, what other complex things could we figure out with just paper and liquid?